Today we are going to do section 1.7. Now before I start, let's first scan in the pages of your book. Here's first, this is the answer sheet. Okay, I want to show it to you now before I forget. Okay, that looks all right. All right. Now here is the first page on page 33. We already scanned this, but I will show it to you again just for convenience. All right. Next, this is page 34, 35. Let's see. Let me get closer. Okay, that looks okay. And then the top. Zoom in a little bit on the top. Okay, and the bottom. All right. And finally, the last page, 36 and 37, we have, this is kind of a short section, that's why we're about done. Okay, we're done so quickly for that reason. Okay, that's the top, and then here's the bottom. All right, so that should be it. So let's start on page 33, 7.1. Okay, now we have the question here is, we have a bunch of equations, right? And the questions, which one is the dependent and which one are the independent variables? If you have a bunch of equations like we did in the previous section, let's look at problem 13 on the previous section, right? We have an equation where u and v, and there's uv, and then there's x, y, etc. Well, who's in the you can pick any of two of them to be the independent variable, and then the other two becomes a dependent variable. So which one? So when we talk about partial u, partial x, for example, which one are we talking about exactly? Well, there are various cases. Okay, you can pick, and that is, any two of them can be independent, and then the other two will be dependent in that particular case. If you have more variables and more equations, the same principle applies. So let's look at some samples. Okay, then let's look at 7.1 on page 33. We have we're supposed to find out partial u, partial x of some function where u is f of x, y, and y is some function of g and z. And we believe that all these things can be pulled out. That is, each one can become independent or dependent as the situation needs. However, for us to find partial u, partial x, u has to be the dependent one, and x has to be the independent one. Okay, otherwise it wouldn't make sense, right? So then we already locked in two variables. So the only thing that can change is the other two variables, which is y and z. They can take turns being being dependent or independent. So case one, where x, the other two variables being x and z, will choose z as the dependent one, y is independent one, and then you will if you do the calculations based on that information, then you come up with a set of answers. Okay, same thing we've been doing previously. So please do that yourself. Okay, and then case two, the same thing. We have now we will change the other two variables, flip them around, so that now y is the dependent variable, whereas x is the independent variable. No, sorry, where z is the independent variable. In that case, then when we do calculations, we'll come up with a different answer that's not necessarily directly related to what we just had before. Okay, so the partial u, partial x really depends on how everything relates to each other. That is how you want this to be done. And so we have in this situation two cases. There's case one and case two. So please work this out yourself. Okay. And so please write this out yourself. Here's what I did. Okay, it doesn't look that much different than what your book has. So if you just follow the rules, that is u dependent on x and y, and z is also dependent on x, y, and bearing that in mind, calculating these things are fairly straightforward, as you can see here. I'm not doing anything that, I don't think I wrote anything the book didn't write already. So, but please do that yourself anyway to solidify the knowledge in your brain. Okay, next. let's look at the following page, page 34, where there's some notation to be said. Now let's look at, for example, to write down that the u is the u is the dependent variable, whereas x, y are the independent variables. That we're gonna think of it that way. We can rewrite case 1, what we just did, in this notation. Okay, that way we know that u is the dependent variable and the x, y are the independent variables, and then z is the dependent variable. It dependent on the x and y as well. So that's case 1. Case 2, different. U is what we're looking. Remember, partial u, partial x is what we're looking for. So partial u, partial x will always be there, right? The only difference is the x and z business. So x and z will, in this case, it will have, case 1 will have x and y as independent. This case will have x and z as independent, but otherwise everything, so this is how we will write the notation with the thing with the subscripts, okay, to make it clear. And in fact, sometimes we even skip the comma and just write down the variables and call it done. But anyway, so that's sometimes that might be helpful. The purpose is just to remind us what are we doing here. Like what is the independent variable that we're taking derivative against, because that matters greatly, right? And so having said that, let's consider partial u, partial y of the same thing, right? Equation 1, yeah, it's what we just did, but 7.2, we're going to calculate partial u, partial y instead. And I don't think that different. Y, x, what's the diff? That is, we'll approach it the same way. First, we remember that what are the independent variables. In the first case, we'll consider y and z as the independent variable, okay, and u and x as the dependent variables, and then we go through the same process we've been doing in the previous section. And case 2, the same thing. We change out the independent variable. Now is z and x, y and x, whereas u and z are now the dependent variables, and then calculate something that result is a similar result. So please write that down out yourself. I have it written down, which I can't. Oh, there it is. Okay, so here's on page. So I wrote this out myself as well, but I don't think there is much difference between what I wrote and what the book did, because everything is fairly straightforward, I believe. Yeah. So that's the second half of it. Is the second half is case 2 is easier because it's shorter and stuff. That's about it. So let's continue. Finally, we see the third illustration, section 7.3, on page 34 at the bottom, where we are calculating partial y, partial x. Now our equations have 3 variables in it. Well, 3 variables change nothing, okay? We're still doing partial y, partial x, so y is automatically the dependent variable, x is automatically the independent variable. However, the other 4 can, switch around, which means we'll end up with 3 cases. So if you look at it, then we have our 3 cases here. Okay, let's see, case 1, and you do the math the same way, and in fact you only have to work on the second equation to come up with partial y, partial x, because well, it just did. Okay, now I mean, take a look. And because we're doing y with respect to x, and they're both in there or something. Anyway, the point is you don't have to work any harder than that. This is it. You partial y, partial x, you came up with 1 over g, g1, and that's good enough for everybody. Okay, so similarly, case 2, to calculate partial y, partial x, you only need the first equation. You don't even care what the other one says, right? Because you already got the answer. So, and then case 3 is partial y, partial x, but this time, due to the other dependent variables, then you end up your equation end up with partial v, partial x in it. See, whereas these ones you don't have other things in it. So then you have to solve both equations and do the Cramer's rule to come up with the answer. Now let me show you what I have. Okay, so there are the cases. Now at first I was a bit confused. You see, I thought there were 4 cases. That is, I thought, well, we have X, it can be XZU and etc. And I got confused as in, I thought X can be equal to something, and because I forgot that we're doing partial. What are we doing here? Partial y, partial x, which means x is automatically the independent variable. So x doesn't equal to anything, okay? So I scratched that out, and which shows that there are indeed 3 different distinct cases, right? Because you can't have x equal to something because we're taking derivative with respect to x. We said that's what we're looking for. So that one doesn't count. And as a result, we have the 3 cases, which I think I wrote down basically identically to what the book did. But please do this yourself as well, okay? And so in the third case, which we have 2 variables, 2 unknowns, so we apply Cramer's rule like we did in the previous section and come up with this answer just like the book. Now with that, we have actually come to the end of this section because this is quite a short section. So let's look at the homework. Now for homework on page 35, please do problems, let's see, 1, 3, 5, 7, 8, 11. For 11, please only do the first half. I mean, you can feel free to do the second half, but I found it rather tedious, so I didn't bother. So I only did the first half. The second half is identical, I think. So that's all I ask you to do is just the first half. And then problem 13, 15, and 16. And when you're done, then let's please come back and let's talk about it. So let's look at problem 1. Problem 1 is, I think, quite straightforward. We'll do as we're told, right? We have this. Here's the problem. First, we need to do with independent variables x and y. So we follow the directions, and stuff comes out. I think it looks okay. Okay, apply the Cramer's rule because we have 2 of them. And then the second one, I think, is the same way. We have, now we have x and u as the independent, so bearing that in mind, so I find it helpful to write down what z is dependent on xu, y is also dependent on xu when you're taking the partial derivatives. Then remember who's independent, who's dependent. Now having done that, then let's write down, take the partial derivatives of the equations, okay, apply Cramer's rule, and here's the answer. And both of my answers was correct. I got it right the first time, which is always awesome. Next, let's go to problem 3. I think we have 2 cases. Okay, problem 3 have functions, and then so we have 2 cases where we have, in the first case, s is dependent on u and r. We are looking for partial s, partial u. Okay, the other case will be s is dependent on u and t, whereas the other variable then will be stuck with dependent with whatever's left. Okay, so bearing in mind these 2 cases, then case 1, we take the partial derivatives, remembering s and t are the independent, sorry, why do I keep messing that up? S and t are the dependent variables, okay? The other 2 are independent. So bearing in mind this situation carefully, then we take the partial derivatives and then come up with some kind of an answer that I hope is correct. I don't think this one has the answer at the back of the book, okay? But that's okay. We similarly, in case 2, we do the same thing, except that now r is the dependent variable. So we pay careful attention to that fact and come up with something that looks similar to this. So it should be correct, okay? And yeah, so that's about that. And let's see, that's problem 3. Next, problem 5. Problem 5, I made a small mistake at first. Okay, problem 5, as you notice, I didn't look at it closely enough. As it turns out, the bottom y equals to x to the power z. I thought it says squared. It's not squared, it's z. Okay, that changes things a lot. So at first I was like, what kind of problem is this? And then, but eventually I noticed my mistake. Okay, see, I screwed up there. So let's so do it again. And so once I do it again, so we have then figure out the cases we have. So what are we looking for here? Partial u, partial x, right? Then the other options, so we have what cases? How many cases do we have? 5. I guess only 2. Okay, so there's case 1, okay, and then case 2, where we have where we follow the rules and the answer comes out rather quickly, and then yeah. So let's see. So that is the right answer, which I checked at the back of the book. Next, let's consider problem 7. Problem 7 is working on the second derivative of problem 3, which the first case is simple enough, right? We just f1 becomes f11 and everything's okay. The second case becomes more involved, but we just have to patiently write it out, okay? And so here's the second case. Being that the partial u, partial x is a bunch of stuff added and multiplied together, we have to calculate the second derivatives. So then we eventually figure out that partial squared x and partial x squared is, okay? And that is g11, and with that information, we basically what we're doing is plugging f1 back into this equation. Okay, so the f1 is now the new f, so to speak. So once you, well, or you can just, well, do it. Either way, the point is eventually when you patiently do this, this is f1, okay, and this is f2 times, let's see, yeah, this is just f2. After you put f2 in there, and then this is the other part of this the product rule. In any case, so once you patiently get through all that, then we got this answer. Unfortunately, the answer is not at the back of the page, so I redid this a little later and on a different day to make sure that I didn't make any mistake, and I was able to come up with the right answer. So that is most likely correct. So next, let's look at problem 8. I think problem 8 is the same thing, okay? So let's do the same thing again. So we have partial v, partial t. Now, so there's case 1 where v is based on t and x, which means so is u. And case 2, v is based on t and u, which leaves x to be based on t and u. So they are the two cases. And then we calculate each one individually, the same way we've always done, and then come up with the answer, which is accurate, a bit identical to the answer in the back of the book. Next, let's look at problems 11. Now, the problem 11 is we're supposed to redo problem 3 or something, and so then we know that the function is s is based on u and r, and so is t, which is fine. Okay, I wrote down the function here in this order where we have f is based on RSTU, so that's g. So then partial s and partial u, which we have already calculated, is equal to that thing. So I wrote it the other way, so to get rid of the negative sign. Okay, and from this point on, then we need to do the squared, the second derivative, which is with respect to t. So that means we're going to apply the quotient rule. However, that as you can imagine, this gets complicated fast. I mean long. And so we have denominator times derivative of the numerator. Okay, the same old thing, minus numerator times the derivative of the denominator. Okay, that's fine. But what is the derivative of the whatever that is? Numerator, right? So I calculated that here, which turns out to be a big long deal. And so is this, okay? The two things, and then that's where I left it, because and theoretically we should probably write this, plug this back in there, and then multiply everything out. But that would mean we're gonna have to write some 60 some terms, which I didn't want to bother. So I'm just gonna leave it like that. okay? But if you want to be perfect, please go ahead and write out all 60-some terms. It will be yeah, good for you or something. Anyway, so that's 11. Now let's look at problem 13. Problem 13, we have actually a simpler situation. Now we have big F equal to 0, where x is given as g and y is given as h. So what I did, I simply plugged it in, those two things, right? So x is g and y is h, and then I took the partial derivatives, which came out nicely and quickly right here. Okay, that is the answer that I came up with. Should be okay because it's short, so there's less likely of me making a mistake. Now, under problem 13, you see, I redid problem 7, the second part, actually the first part as well. So I redid problem 7 to make sure that I got it right. At least I come up with the same answer, okay, on a different day, and I did. So it's very likely the correct answer. So, and then let's move on to problem 15, which in this case, we're just trying to calculate 3 cases of something, which is fine. Right? No, we are also trying to, give me a second, what? Oh, right. If problem 15 says that we need to show that partial y partial x is 1 over partial x partial y for that particular problem in all cases, which we have 3 cases. So, well, we're just going to go ahead and do that. Here's case 1, okay? After you calculate it, that's, I think that's quite short. And then partial x, I figured out partial x, partial y, and partial y, partial x. And so case 2, same thing. Okay, we have partial y, partial x there, and partial x, partial y is here, which happen to be the reciprocal, is what they're called. Right? Right. And then finally, case 3 is slightly more involved, but no different. Okay, the principle applies. First, I calculated partial y, partial x, and then I calculated partial x, partial y right here, which happens to be the reciprocal of that other thing right here, up here. So that is that. Now, finally, let's look at problem 16. Problem 16, the book that has not even going to bother writing out the equations for you, which is okay. We can write it out ourselves. Okay, here are the 3 equations. I wrote out one of them. The others are the same. And we have f. Okay, we have 7 variables, which means let's number them. Okay, 1, 2, 3, 4, 5, 6, 7, all numbered so that we know what F1 or F6 or whatever it is. So now that we know this, let's take, what are we doing here? Let's see, and let me take a look to see what we're doing. So we have 3 dependent variables based on 4 independent variables, which is fine. In fact, I did some of this stuff, but then I decided, why am I even going through this? I mean, this tells me this is the same thing, okay? And it's better if we just pull out the Jacobian. So by the principles of the Jacobian, then we write down what are these? The dependent variables, right, on the bottom, and that's the v. So v is lined up here, and then with respect to y, so we put y where v used to be, okay, and then take and then this is the Jacobian solution for this thing, okay, partial v, partial y, and we do the same thing with partial y, partial v, and let's write it out exactly the same way. So we have tvx here, and we replace in this case. Let's see, v replaces where y used to be, okay? So then we compare these 2 things, and they are the same. Therefore, the reciprocal is, let's see, wait a second, it doesn't equal to it, it's supposed to be 1 over. I forgot to write down the 1 over. Let me write that. All right, now that's better, okay? See, it equals to 1 over that thing, which is what we're supposed to do. Because, well, this happened to be tvx, okay? Which is in the denominator up here, and similarly, this is the tyx is up here. So we'll just quote the Jacobian and call this thing done. And that marks the end of this section.